Okay, so this concept that we are going to discuss is nothing but the coalescing, the isothermal coalescing of soap bubbles, right? And the idea behind this is this much only, that if you have over here, let us say two of these drops, right, and let's say that they may have different radius also, right, and we want to know that after they coalesce over here, right, they combine over here, and what would be the radius of the other one, right, what would be the radius of this particular one, right, that we want to find out, let us say. So therefore what we do in such cases is that, let's say that the radius over here, let's take it as equal to c itself. This one over here, it has a radius of a. This one over here, it has a radius of b itself, right? Now it is not necessary that the volume must remain a constant value, because the gases over here, they are compressible in nature, right? The pressure over here is P1, the pressure over here is P2, and the pressure over here is let's say it is P3 itself, right? So therefore, if this is the situation, then we notice that the number of moles of the gas which is present over here, that is the one that will remain a constant value. This is the concept that we'll be using over here, in addition to the excess pressure being inside a soap bubble as equal to how much? Excess pressure being inside as equal to not 2T by R. The excess pressure inside a soap bubble is because of two interfaces, you will be having over here a excess pressure of 4 times of T by R. Let's apply that over here, number one. So the outside pressure is nothing but atmospheric, therefore we can write over here, what is the objective? Objective is to find out how much is the radius of the final soap bubble after these two have coalesced, after these two have combined, right? So we can write over here that P1 is nothing but equal to 4T divided by A plus P0. Why? Because excess pressure, since excess pressure is nothing but the inside pressure minus the outside pressure is nothing but 4T divided by the radius of curvature itself, right? So therefore over here for the first bubble this is the case. Similarly you can write for the second bubble, it is 4T by B plus P0. Sorry. Similarly for the third bubble, it is 4T divided by C plus P0, right? And the second concept is that we will write the number of moles as a constant. That means N1 plus N2 must be equal to N3 itself. Number of moles using your ideal gas equation, what can you write that as? Pressure P1 V1 divided by R into the temperature plus P2 V2 divided by R into the temperature. Again isothermal only, so all the temperatures, the temperatures, all the three are the same, and that we are taking in as T itself. So you can write P3 V3 by R into T itself. Removing the RT values over here, you get P1 V1 plus P2 V2. It must be equal to P3 times of V3, right? That's all. Now let's substitute the P1 and V1 only. P1 is there, you can see where it is. Substitute that. What do you get? 4P by A plus P0. Volume of the first one is a sphere of volume, sphere of radius A, that is 4 by 3 pi A cube, and similarly for the other one, 4T by B plus P0 into 4 by 3 pi into B cube. On the other side it is 4T by C plus P0 into 4 by 3 pi times of what cube? C cube. That's all. And now we are ready to extract the value over here. So therefore, why don't we cancel the 4 by 3 part on all the sides, and we get over here this as 4T multiplied by a square plus b square minus c square, correct? And what else you'll be having? Plus p naught multiplied by a cube plus b cube minus c cube. This is equal to how much? This must be equal to 0 itself. Yeah, we were intending to find out the value of the radius, right? This is actually a cubic equation, and you have to find out what is the value of you have to find out the value of the c over here. If you solve that cubic equation, who will solve that? You only. You can solve that cubic equation, and finally you will arrive at the value of c itself, right? For now, let us just find out what is the atmospheric pressure or the surface tension value. So you can always write P naught as equal to how much? Shift the terms on one side. P naught will be a cube plus b cube minus c cube, and on the numerator side you'll be having 4t into c square minus a square plus b square, right. So I think this is your atmospheric pressure, and you can also find out how much is surface tension, and you can also therefore find out what are the other quantities like the C1 over here. Yes, this part is clear, no doubts are there. Yes. Right, that's it, gentlemen. Thank you for attending.